Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 8th students of various branches for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8th. Our ongoing chapter, that is chapter number 6, sound. Today we are entering into the session number 2. So we started this particular chapter in the last week, and we'll continue where we left in the last class. But before that, let us rewind, let us review, let us recall what we learned in first session. So as you know, the topic sound, we learn first about what is sound, right? Then how sound is produced. Second question, why sound is produced. Another question we clarified. And how sound travels. How sound travels from source to observer. And some few terms related to sound. These are the things, that is, which are the basics, basic introduction to the sound we discussed in the last class, right? So what is sound? So you are clear which is the sound is the form of energy which is pleasant to hear. Which is pleasant to hear. It should be pleasant. It should produce the pleasing effects on eardrums. Such a form of energy is called sound. If it is not pleasant, that is called noise. Noise is the reciprocal of the sound. Right? Then how sound is produced? Second question. Vibration of the body. Sound is produced by vibrating bodies. Or to produce sound, body must be in vibration. Without vibration, there is no sound. Right? Then why sound is produced? So during the vibration, the molecules collide with each other. When one molecule collides with the neighboring particles, the sound is produced. So due to vibration, due to the continuous collision of molecules with each other, sound is produced in solids, liquids, or even gases also. As there is no matter in the vacuum or space, sound cannot travel through vacuum. Sound cannot travel through vacuum because there is no matter in the vacuum. Vacuum means nothing but absence of matter. There is no matter. Right? So sound travels generally in the form of a wave. Sound always travels in the form of a wave. So what is wave? You may get doubt. What is wave? Wave is nothing but a disturbance created in a medium. When you create, suppose I am clapping. What happened? There is some disturbance in the air particles. So what these air particles will do? They will pass energy to next particle, next particle, next particle. The sound will go up to some distance. Even people who are near to me can able to hear that I am clapping. Or even you can also hear, because of, even though you are in the 10 kilometers, 20 kilometers or 50 kilometers distance. That is because of the air particles, or because of the water also you can, because of sound. If you hit the any sound also, you can get the sound because of the sound travels forward from the point of disturbance. Such traveling is called a wave motion. Right? When disturbance created in a medium, the disturbance propagates forward in the form of energy. Particles never move, particles remain there only. Only energy transforms from one particle to another particle. Like that, sound can travel in the form of a wave. Right? So, till that, we'll discuss in the last class about how sound travels. See here, in the form of a wave, the various way the sound is, that is called a wave motion. This is a wave. Okay. So in the form of pulse, that is called pulse. One of wave is called a pulse. Number of pulses combined to give a wave. And such motion of the wave is called a wave motion. Because of the movement of transfer of energy by a particle, wave moves forward. Okay. Now, we'll discuss about some important terms related to waves. So there are so many types of waves are there. But before that, some terms you discuss. Suppose, very important. Say this is a wave. We disturbed here. The wave formed like this, right? This is completely wave. And this part, one part is called a pulse. Right? See, when you disturb here, particle go up to maximum distance here. And again coming down. This highest point is called crest. What is called? Crest. Highest upward or downward displacement. Upward displacement. Again, it comes down here. And this part is called trough. Trough is nothing but bowl. Because the bowl-like shape you see here. The shape is like bowl. Trough. Crest. So this is a crest. Trough. 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 So these all are the crest. These all are the troughs. So sets of crest and troughs makes a wave. When number of crests and when number of troughs makes a wave. And see, this is the highest point. Above this particle is not moving. So the highest displacement, either upward or downward, is called amplitude. Everything is there only. The amplitude is nothing but the maximum displacement of the particle from the point of disturbance. See, the distance between successive crest or successive trough is called a wavelength. Everything is mentioned here. Wavelength. Wavelength is nothing but the distance between two consecutive crest or two consecutive trough. Consecutive means first crest and next trough. First trough and next trough. Immediately. It is called as a wavelength. These are the few points which will come across when you are studying about the wave. See here. Crest. It is a point of maximum displacement of a particle in upward direction. This, and many more. Then trough. It is a point of maximum displacement of particle in downward direction. Downward direction maximum is this. They are called troughs. Amplitude. It is a maximum displacement of particle from the mean position either in the upward direction or downward direction. Maximum displacement. So either upward or downward. What is the maximum here? This is called as a amplitude of a wave. It is the distance between any two successive crest or trough. Successive means first and second, or second and third. First and next crest or next trough is called as a wavelength. See here. Time period. It is a time taken by a particle to complete one oscillation. So here particle comes from here down again come back to here. This is called the time taken. So what is the time taken by a particle to go to the highest and come down to the normal position? That is called time period. Then another very important one. Number of oscillations or vibrations made by a particle in 1 second. In 1 second, how many vibrations the particle of either liquid, gas or solid can do? That is called as a frequency of a wave. So that is mathematically given by, it is generally represented by nu or sometimes n also. is equal to 1 by t, number of vibrations per second. T is the time. So frequency is equal to 1 by t. Right? Even time period also nothing but you can write 1 by nu. So the frequency is measured in units called hertz. We already discussed it. Because when you are discussing about whether can you able to hear all the sounds or not. No, we cannot hear all sounds. Only we can hear only up to our audible limit, which are called audible range, 20 hertz to 20,000. Below also we cannot hear, above also we cannot hear, which we discussed in the last class. So, yes, the unit is hertz. Velocity, another important word. Velocity, common, in the kinematics you learned. It is the speed with which the wave propagates in the medium. Velocity is the speed. The distance traveled by a wave in a given time is called as a velocity of the wave. Very important formula is the velocity. Velocity is equal to distance is not, what is the distance here? We can take wavelength. Distance by time. Wavelength is denoted by a lambda. Greek word, it is called lambda. That is nothing but distance only. So V is equal to distance by time. So you can write distance into what is 1 by t, you can write now. Same meaning. Lambda into 1 by t is lambda t1. What is 1 by t is nothing but frequency. So you can write V is equal to frequency into V is equal to frequency into lambda is the formula for velocity of a wave. What? Velocity of a wave. So these are the few terms, terminology which will come across when a wave is created in either in solid, liquid or gases. Then the wave moves forward in the form by transferring the energy to next particle, and finally reaches a mean position. Okay. Then some more terms are there, like before going for the waves, right? Simple terms. Pace. Pace. Pace is nothing but same line. See, what is pace? Describes the motion of the vibrating particle and their direction of motion. In which direction the particles are moving. The showing the direction of the particles and that is the motion of the particle is called pace. For example, see here. Just a minute, I'll tell. See, if you draw a line here, to draw a line to the wave and downwards also, see, few particles are in same line. They are said to be in same pace. They are in same pace means they are lying on the same plane. The number of particles which are in same plane are said to be a same pace, which indicates the motion and direction of the particles. Right? Similarly, same pace, that's what given here. Particles that are at the same distance from the mean position and have the same velocity at that moment are called same pace. Different pace. Two particles having different displacements. One is at top, other is at bottom. Crust is not in same pace with the trough. All crusts are in same pace. But crust and trough are in the different pace. Right? Then out of pace. Two particles having the same magnitude of displacement or mean to have position and velocity but having the opposite direction motion are said to be out of pace. So when they are moving, the crust is a different direction will move, trough is a different direction, upward, downward. So crust and trough are in the out of phase. They're making some angle with each other. Okay. So these are the important terminology related to the waves. When the sound travels in the form of wave, in wave will come across crest, upward displacement, trough, downward displacement, amplitude, maximum displacement, wavelength, distance between two crusts or two troughs, time period, time taken by a particle to complete one oscillation or vibration, frequency, the number of oscillations per second, number of cycles per second, number of vibrations per second, which is measured in hertz, velocity, the speed of the wave, pace, same pace, different pace, out of pace. Okay. These all in details will come across when you go to the higher classes. Now, very important point is about the waves. So before going to explain, there are so many types of waves are there. Basically, mechanical waves and electromagnetic waves. These are best qualification. In that again, you come across transverse mechanical waves, longitudinal mechanical waves. They are mechanical. Then one more is there stationary waves and progressive waves. Electromagnetic waves are different category, which can travel even through vacuum also. So before discussing about this, let me show you one video on same. Then I'll explain, right? Watch the video carefully about the types of waves.
Hello friends, so today I'm going to introduce to you a very interesting topic, types of waves. In our last module, we've discussed about a wave. So how do you describe a wave? A wave can be described as a disturbance that travels through a medium from one location to another without transporting any matter. That's a point to ponder. Without transporting any matter. Do you know what a mechanical wave is? Here, I'm going to give you a brief introduction about a mechanical wave, and the detailed information I'll share with you in my next module. Okay, so a mechanical wave is nothing more than a disturbance which is traveling through a medium such as a solid, liquid, or a gas, as you've seen in the case of water waves that are formed when I throw a stone into the lake or a pond. That's as simple as that, as a mechanical wave. Now this disturbance so created in the lake is caused due to the to and fro motion of the water particles. So now in this module, we are going to discuss about the various types of waves. Like in a previous module, we have taken a situation where a group of people were standing in a queue and all of them was holding each other through their shoulders. So what did we observe over there? What was actually happening over there? When one person sits down, he pulls his neighboring person to sit down as well. And when he stands up, he again pulls his neighboring person to stand up. So it keeps on moving that way. So each person here is undergoing only up and down motion. And this disturbance is propagated towards the last person of the group. Similarly, we can take an example of a rope. So if I have a rope with me, you can see here, the disturbance, it travels through the rope. And how this is traveling through the rope? Let's see. What do you see if you carefully observe this rope? Yes, if you carefully observe this rope, then you must have noticed that the red dots, the red dots which are present on the rope, they keep on undergoing to and fro motion about their mean position. While the disturbance, it keeps on traveling forward through the rope. So what do you conclude from the above two examples? So it is concluded that it is the disturbance that is carried forward, but the particles of the medium, they are undergoing to and fro motion only, and that is about their mean position. So here the waves, they move straight from one end to the other end, while the particle motion which makes that particular wave is in a direction which is perpendicular to the direction of propagation of the wave. Now this type of wave is called as, any guesses? Yes, this type of wave is called as the transverse wave, in which the particles of the medium, they move in a direction which is perpendicular to the direction of propagation of wave. And some of the examples of transverse waves are the water waves, which are formed when I drop a stone into a lake or a pond, the light waves and the radio waves. These are all examples of transverse waves. Now let's do a simple activity to demonstrate how a transverse wave looks like. Let's take a slinky and place it on the table, and we're fixing its one end and the other end is let free. Now I hold the free end of the slinky and just whip it.
You know slinky, na?
What do we observe? The slinky, it appears to move like a snake, and it shows a wavy appearance. What kind of wave does this vibrating slinky represent here? Yes, we studied this, and it's a transverse wave. A transverse wave in which the particles undergo to and fro motion about their mean position and moves in a direction which is perpendicular to the direction of wave propagation. Now we'll take the same group of people that we had taken earlier, but this time with a slightly different arrangement. And let's see what happens. So here's the same group of people, but in this case, they're not holding each other through their shoulders, but through their elbows. Now in this case, the first person, he gently pushes the second person sideways and then pulls him back. You see this push and pull moment, and this is propagated towards the last person of the group. So how is this moment different from the previous one, where each person is holding each other through their shoulders? Now that's something which we have to look forward to. You can see here in the previous case, each person was undergoing up and down motion, while in this case, each person is moving back and forth about their mean position. And the push and pull is transmitted to the person at the end. Now consider the case of a slinky whose one end is fixed to a point. What happens? Now I give a sharp push to it, and what do we observe? Yes, you observe that some sort of disturbance is carried forward from one end of the slinky to the other end. What is this disturbance? This disturbance is carried forward while all the rings of the slinky are moving back and forth about their mean position. But the disturbance, it gets carried forward. Now if I push the slinky forward and backward continuously, then what do you see? It's another interesting thing that we observe. You see here a series of compressions followed by rarefactions, compressions and rarefactions, where the compressions are the regions where the rings are crowded together and rarefactions are the regions where the rings are far apart. So compression and rarefaction both move forward. And in this case, wave motion is in one direction, and the motion of particles of the medium are in a direction which is parallel to the direction of propagation of the wave. Now what do we call this kind of wave? This presents us the second kind of wave, which is known as the longitudinal wave, in which the particles of the medium, they undergo back and forth motion about the mean position, and this is parallel to the direction of propagation of wave. And some of the examples of longitudinal waves are the sound waves. So when I'm speaking, the sound wave which I emit from my mouth is an example of a longitudinal wave. So let's summarize till now whatever we have studied. We've studied that there are two types of waves, a transverse wave and a longitudinal wave. A transverse wave in which the particles of the medium move in one direction, which is perpendicular to the direction of wave propagation, and they oscillate about their mean position, to and fro motion. The examples were a ripple on a pond or a lake and a wave on a string. They can be easily visualized as transverse waves. Some of the other examples that we studied about were the light waves, the heat waves, and radio waves. All are examples of transverse waves. Now coming to the longitudinal waves, the second kind of waves, in which the particles of the medium, they move in a direction which is parallel to the direction of wave propagation. And we had the examples of sound waves, a wave in a slinky. So these are good visualizations of longitudinal waves. So this is all about the types of waves, and in our next module, we'll discuss about sound waves in detail.
Right. So wonderful explanation in advance for our entire topic here. So how nicely explained, what we can see the same example even in the stadiums, football or cricket stadium. You see, they'll hold their hands and they'll go for the wave show. So that is nothing but our either transverse waves or longitudinal, both. If shoulder to shoulder touch will give the perpendicular up and down motion will give the transverse waves, and to and from motion will give the longitudinal, the simple way of explanation. Wonderful way of explanation, right? So before that, once again we'll recall. So mechanical waves, the name itself indicates the waves produced by application of force. The mechanical waves are the waves that are required medium for their propagation. Example, sound waves. So these mechanical waves require medium. It's not Telugu medium, Hindi medium, Urdu medium. Medium means a matter. Either it may be solid matter, liquid matter, or gas matter. These mechanical waves cannot travel through vacuum because vacuum does not have any matter. So that is the sound waves or the mechanical waves which are produced by the vibration of the particles. And the second kind of motion is electromagnetic waves or second electromagnetic waves. Very interesting. Right? So electromagnetic waves are the waves do not require any medium for their propagation. Light waves. Electromagnetic, name only indicating both electric and magnetic fields combined, like sunlight, solar light. Lighthouse light is reaching our earth, passing through vacuum. Means it can travel through vacuum also. It does not require medium for propagation. Such kind of waves are called electromagnetic waves. Right? So these two waves, example if you see, first only we discuss about mechanical waves in this class. When you go to the higher classes, you will see so many examples of the even electromagnetic waves also. Okay. So classification of waves based on direction of vibration. Just now we have seen a video. In which direction particles are vibrating. Whether they are vibrating perpendicular to the direction of wave motion or parallel to the wave of direction. If they are perpendicular, they are called transverse waves. If they are parallel, they are called longitudinal waves. That is the reason I showed you before only. Right? Parallel. What is parallel? You understood. What is perpendicular? You understood. Up and down motion. To and fro motion. To and fro and up and down. Right? Okay. So when you see the first type of wave, transverse waves. In the longitude, so I think they are just change the names here. This should come this side, this should come this side. Change in your textbook also. There is some correction is required. Okay. So this column is given as a longitudinal waves. Please change your textbook. This one is longitudinal mechanical waves. And this one is transverse mechanical wave. By mistake, it is came like this. Okay. So this is longitudinal. So in a transverse, when you see, in transverse waves of the medium of particle vibrates perpendicular to the direction of propagation. Example, when stone is dropped into pond, just now is shown also. Transverse waves are produced. In transverse waves, crests and troughs are formed. See, this point is called crest, already we have seen. This point is called trough. Crest, trough. Okay. Then in graphically diagram we have seen. Now when we come to the longitudinal waves are the medium particles vibrates parallel to the direction of wave propagation. Like you also slinky. Slinky we have seen are the people holding their hands. That is, in longitudinal waves, compressions and rarefactions. When spring is compressed, come close, compressions. Moves away, rarefactions. Compression, rarefaction will come like this. Just example is given here. Right? That is the long. Please remember, you change the headings. First one as longitudinal waves, second one as transverse waves. There is a mistake. Okay. See, this is the how the crests and compressions, rarefactions, and crests and troughs are formed. Okay. These waves can be produced in liquids, solids, and gases. Which one? Longitudinal. These waves can travel solids and on the surface of the liquids only. This is only solids and liquids, transverse. Whereas longitudinal can travel through all the three. Clear? This is about the two kinds of waves based on the direction of propagation. Whether particles are moving perpendicular or parallel. If they are perpendicular, called transverse. If they are parallel, they are called longitudinal. Okay. Then comes another classification is there. Based on wave motion. One is based on direction. The second one is based on wave motion. How wave is moving. Based on that, they are called as progressive waves, stationary waves. Very simple. Progressive means which moves forward. They never come back again. Suppose if you drops thrown into the ocean or a sea. Waves are formed and they'll go up to infinite distance. We don't know where to stop. As long as energy is there, they travel. Whereas the waves formed in a rope. Tie rope at one end of the wall and hold second end in your hand and plug the rope. The waves go forward. After striking the wall, again they'll come back. They are called stationary waves. That is progressive, digressive. When they overlap with each other, the stationary waves are formed. See here. You can clearly see this is the progressive waves keep on moving. They are the digressive waves. Forward is called progressive, reverse is called digressive. That means they are forming the stationary waves. Clear? So, the wave starts at a point and move to all parts of the medium of space or space. These waves transmits energy from one place to another. The energy processed by these waves is kinetic in nature. Because of that, they are moving. These waves contains crust and troughs or compressions and rarefactions. Whereas stationary waves, these waves appears to standing at a place and are conformed to between the 2 points, conformed limited. So rope cannot go beyond the wall or it cannot go beyond your hand. It is between your hand and wall only. Keep on moving here and there. These waves store energy in them. Their potential. The energy associated with this is potential because it is at position. These waves contains nodes and antinodes. See, these points are called nodes and these points are called antinodes. They all nodes only upward or downward. Maximum displacement are called nodes, antinodes, and they are called nodes. Contains nodes and antinodes. So these are the classification of the waves based on wave motion. So waves can be classified either on based on the direction of propagation or direction of wave motion. Direction of propagation is transverse and longitudinal. Please change the heading of that. And second classification is based on their wave motion as progressive and stationary. Right? So in next class when we meet, we'll discuss more and more about the how sound waves are produced and what exactly is required, properties of sound waves. Totally about sound waves only. Some more explanation about the sonar, ultrasonics and all, and factor influence in the sound, where sound travels with more speed, where it travels at less speed, and so many things are there. So many examples which will come across in our day-to-day life. Along with that, finally we end with the problems or the numerical practice. Okay. So that's all for today. What we learned about the waves and types of waves and various types of waves we have seen like this. Either it may be transverse or longitudinal or stationary or progressive. Right? So that's all for today. Thank you all of you. Have a wonderful day. Thank you.